So my name is Jiho Eun. I'm currently going to NLCS Jeju and I'm in year 11 in Seoul in Jeju, South Korea. The title of my patent is Eco-Friendly Biodegradable Buoy Incorporating with Aluminum Framework. So the field covers marine sustainability and smart ocean solutions. So it is dedicated to developing innovative technologies and strategies that promote the long-term health of marine ecosystems while ensuring sustainable human use of ocean resources. As the ocean faces increasing threats from pollution, climate change, and overexploitation, the need for eco-friendly solutions have been more urgent than ever. Now the background. South Korea's aquaculture industry plays a pivotal role in its economy, with oyster farming being the significant contributor. A crucial component of oyster aquaculture is the use of buoys to support farming structures. Traditionally, these buoys are made from expanded polyester, commonly known as styrofoam, due to its buoyancy and cost effectiveness. However, EPS buoys present significant environmental challenges. First of all, fragmentation and marine debris. The styrofoam buoys are prone to fragmentation, leading to substantial marine debris. Studies have shown that these buoys can break down into microplastics, contributing to plastic pollution along coastlines. Second is the microplastic pollution. As styrofoam buoys degrade, they release microplastics into our marine ecosystems. This pollution poses threats to aquatic life and raises concerns about food safety. Toxicity from photodegradation. Research indicates that chemicals generated upon the photodegradation of EPS buoys can increase toxicity in marine environments, further harming aquatic organisms. So my idea came out with the biodegradable buoy. Now I'm going to talk about the design and functionality. The key features are first, aluminum outer cage. It provides a strong corrosion-resistant frame to support the buoy structure. It ensures the buoy maintains shapes and functionality even in harsh marine conditions. And also it acts as a protective shell for the biodegradable material inside. Second, the biodegradable core with replaceable slots. The inner section is divided into 4 slots, allowing for modular biodegradable inserts. These inserts degrade over time and can be replaced every 2 years, ensuring continued buoyancy without environmental harm. The design allows for gradual decomposition, reducing plastic pollution compared to conventional EPS buoys. Now moving on to future implications of the biodegradable buoy. First, I'm going to mention about the transforming Korea's aquaculture industry. So South Korea is already a global leader in oyster farming, producing around 300,000 tons annually and aiming to increase production. As the government pushes for eco-friendly marine policies and the adoption of biodegradable buoys could become a national standard, replacing the harmful expanded polyester buoys currently in use. Expanding to the global oyster and aquaculture industry. Oyster farming is a multi-billion-dollar industry worldwide, with China and the US. Many of these countries also struggle with plastic pollution from aquaculture equipment. A scalable and adaptable biodegradable buoy could be and used beyond the oysters, benefiting mussel, scallop, and fish farming operations. So it has a large impact to the whole world. Encouraged by international organizations such as the FAO, Food and Agriculture Organization, which promotes sustainable fisheries and aquaculture practices. By positioning biodegradable buoys as a global standard, South Korea could lead the market for sustainable marine equipment, driving exports and setting an example in marine conservation efforts. And finally, we can enhance sustainability of the buoy design. To further improve sustainability, additional innovations can be integrated into the buoy system. So the idea I came out with are the biodegradable anchoring rope and smart buoy technology integration. So first, I'm going to first talk about the anchoring rope system. Traditional ropes are made from nylon or polypropylene, which degrade into microplastics. So it is a problem. We're going to replacing them with natural fiber ropes that can ensure that every part of the buoy system is biodegradable, being a more sustainable solution to the ocean. And second, the smart buoy technology integration, adding RFID chips or biodegradable sensors can track degradation rates and notify aquaculture workers when inserts need replacement. This will make the maintenance process more efficient, reducing the unnecessary replacements. Combining biodegradable buoys, ropes, and smart tracking systems can ultimately eliminate plastics waste from aquaculture operations, making seafood production more sustainable, profitable, and a global responsible solution. This innovation has the potential to redefine marine farming practices worldwide, ensuring that the ocean remains healthy for future generations while supporting economic growth in the aquaculture sector. Now the benefits to society. The major benefit to society is reducing microplastic pollution and environmental impact. One of the biggest environmental threats from conventional aquaculture is the breakdown of expanded polystyrene, which degrade into microplastics over time, persisted in oceans for decades. Accumulating in water columns and seafood sediments, it is a long-term problem and are ingested by marine organisms, disrupting ecosystems and entering the food chain. It also contributes to global plastic pollution, which is estimated to exceed 26 million tons annually in the ocean. By replacing the styrofoam EPS buoys with biodegradable alternatives, it prevents microplastic generation in marine environments, and it reduces cleanup costs and even meets stricter global environmental policies. With countries like South Korea already banning styrofoam buoys, implementing biodegradable alternatives ensures a cleaner, more sustainable marine industry. The second benefit to society is protecting marine ecosystems. Microplastics and EPS buoys pose serious threats to marine diversity, affecting both open water species and coastal ecosystems. Toxic chemicals when exposed to sunlight and seawater, it disrupts the food chain as fish and shellfish mistake plastic for food. It also damages seagrass beds and coral reefs, essential for marine biodiversity. By switching the biodegradable buoys, oyster farms and fishery environments remain clean and pollution-free, and seagrass, corals, and other marine habitats are preserved. And fish, crustaceans, and seabird face less risk of plastic ingestion and entanglement. This is not only benefits wild marine species, but also supports sustainable fisheries, ensuring long-term seafood production without harming the environment. The final benefit is the health benefit for humans. Microplastic and their associated chemicals have raised major health concerns as they are now found in seafood, drinking water, and even human blood. The ingestion of microplastics can introduce harmful chemicals into human body. They affect metabolism, hormone balance, and gut health. It poses long-term risk of inflammatory diseases and organ damage. Because aquaculture supplies a significant portion of world seafood, eliminating microplastic contamination in farm shellfish, such as oysters, is a critical for food safety. By removing the EPS-based buoys from industry, consumers can trust that seafood from oyster farms is free from plastic contamination, and the seafood industry benefits from cleaner, more sustainable practices, increasing the market demand. Public health risks are reduced, and fewer plastic-replaced toxins enter human diets. So it is overall a cleaner future for society. The transition to biodegradable buoys represent a major step towards the marine sustainability. It directly addresses the plastic pollution crisis, protects marine ecosystems, and improves human health by reducing plastic exposures through seafood. By adapting biodegradable solutions in aquaculture, we create a future where marine farming is both productive and environmentally responsible, ensuring healthier oceans, safer food, and cleaner planet for our future generations. Thank you.